All right, hi there. This is video number 27. And this is chapter 11, section 4. And this is all about series and their notation. All right, so the first thing is that you're going to see these have a big giant Greek E. So this is a capital E in the Greek alphabet, and it's called a sigma, and it is the Greek letter for summation. And summation means add, right? Sum everything up. So what you're going to see is some notation around it. And that notation, Varsity uses I's. I've always seen N's, but whatever. So you're going to have an A and a B mostly in Varsity. So what you've got here is this means, oh, and then you've got this function over here, f of x sub I, essentially. So it means to find the sum of a sub I, or f of x sub I, from I equals A to I equals B. Typically, A will be 1. Not always, but typically. And you never know how high B is going to go. It will tell you, or you'll have a number of terms, and you'll be able to tell from there. Let's see. Something else that you should know is I is called the index of summation. And I say you need to know that, but quite honestly, I didn't know that. So it's something I found in the reading, but it'll allow us to talk about, if you say, well, the index of summation, it goes from 1 to 6 or something like that. And we'll know what we're talking about. So where A, we'll put a comma here, where A is the lower limit, and B is the upper limit. And this doesn't make a whole lot of sense in these generic terms like this, but we're going to look at some very specific ones here in a minute. Like right now, we're going to look at some specific ones and what they mean. So here are some popular series. And what I'd like you to do is, I have 1, 2, 3, 4, 5 across my page. So let's see, I don't know if I can fit them all in here, but I'm going to try. I'm also going to write that better than that. I'm going to use one line per sigma. So 1, 2, oh, I can easily fit 5 across this page. I'm going to give myself a little bit more space. 1, 2, 3, 4, 5. Maybe we'll throw a 6th one in there. I don't know. All right, so this is what we're going to sum. We're going to go where I goes from 1 to 5. In every single case, we're going to do this the same. So the summation, or the index of summation, is going to be from 1 to 5. Okay, and then here's what we're going to sum up. The first one's going to be 2n. The second one, or 2i, I guess. See, I'm so used to, I put n's in my notes too. Let me get rid of that. That needs to be an I. All right, and then 2i minus 1, and then I squared, and then 2 to the I, and then I exclamation point. And we'll talk about what that means if you haven't ever seen that in math. That is actually a math symbol. It's on a calculator. It's in a calculator. I mean, you have to kind of find it. But all right, so if you want to, and I don't know if it'd be wise, but essentially I'm going to build these down in columns underneath the summation. So what we're going to do, and I'll use different colors to do this, is I'm going to have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. And I want you to see what these things look like. So remember, the I is the subscript. So this is 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. And 2 times 5 is 10. So what we're getting here, 2, 4, 6, 8, 10, you could see if we kept on going, we'd get 12, 14, 16, blah, 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 blah. So what we're actually building there, I'm going to expand my page, is we are getting even numbers or multiples of 2. And the reason that's important here, if you actually look down this, we've got the 2's are a common, right? And then next to it, you've got your A value or your I value, 1, 2, 3, 4, 5. So if instead of a 2 underneath that highlighting, you had a 5 underneath that highlighting, you'd build 5, 10, 15, 20, 25. You'd build multiples of 5, right? So this could be a 5i out here. So you can have multiples of a number by changing the coefficient out here. This just happens to build you evens or multiples of 2. Okay, so that's important. Also look at, sometimes it's nice to look at and focus on the values between the numbers. So if you take a look at the numbers between these, you get a 2 between every single one of those, right? And I'm not going to leave those in there because I don't really have enough space, but that's important to kind of take note of when you're looking at functions later to try to build the function, that you can focus on those sometimes. So I'm going to get rid of those. All right, next one. I'm going to change my pen color, hopefully kind of dramatically enough to see a difference. All right, so a sub 1, a sub 2, a sub 3. And now I'm taking 2i. Well, this is 2i over here. So I'm just going to take my values and subtract off 1. So 2i when I is 1 is 2. Subtract off 1. Then 4 minus 1, 6 minus 1, 8 minus 1, 10 minus 1. And what I'm getting is 1, 3, 5, 7, and 9. So in this case, what I'm building down here are my odd numbers, right? So I'm taking an even and I'm subtracting off 1. All right. Oh, I just thought of another one that we should maybe look at. All right, we'll maybe add that. Okay, next guy. I'll do this one in orange. And this one, let me get rid of this. All right. Orange pen. All right. A sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. All right, so this guy, what we're doing is taking the I value, the subscript, and raising it to the second power. 2 squared, 3 squared, 4 squared, 5 squared. So here I'm just building perfect squares, right? Is all I'm doing. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Now these, it's interesting. I didn't look at the difference between the odds, but they're all 2, just like they are on the evens. And your perfect squares, this is kind of interesting to look at the differences between the terms because something interesting happens. And again, it can help you later on. Between 1 and 4, you have 3. Between 4 and 9, you have 5. Between 9 and 16, you have 7. And between 16 and 25, you have 9. So you will actually, between the next term is 36, right? 6 squared is 36. That's 11. And then the next term is 49, and that's 13. So you're actually building up 3, 5, 7, 9, 11, 13. It's an incremental odd numbers is how this change builds up. And this is important when you see some of these series to remember that the powers, perfect squares, that the difference between them goes up incrementally by odds. I don't know if that's the way to word that or not, but I think you know what I mean. I hope you know what I mean. All right, and then I'm going to go back to green. So this guy is 2 to the I. So we have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. And we're going 2 to the 1, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. And these are things you definitely should know off the top of your head, all the way at least to 2 to the fifth, if not 2 to the sixth. So, and remember, anything to the 0 power is 1. Don't forget that. So if you had 2 to the 0, that would be 1. 2 to the 1 is also, this is 2, right? 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. And so it's interesting with these guys, if you look at the difference between them, you get 2, 4, 8, 16. You actually get the powers between them. So that's an interesting thing to note with those guys. So these are powers of 2. Okay, so the factorial. Let's take a little note down here. A factorial is represented with an exclamation point. It's popular and used a lot in probability. Oh, that's not an L. Probability. And what it means is, here's the definition. So if you have, let's say, an n factorial, this means you start at n and you multiply by every number less than that. So you then multiply by n minus 1, n minus 2, times n minus 3, blah, 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 until you eventually get to actual numbers, and then you go 5 times 4 times 3 times 2 times 1. So if you have a number, let's say you have a 6 factorial, that is, you start at the base and you just multiply down to 1. 6 times 5 times 4 times 3 times 2 times 1. If you go to most applications or calculators, you can find a factorial. You just may not be aware that it's there. So I'm going to pop out here to Desmos. And if you go from main function over to regular function, you'll see, whoop, go away. You will see this question mark or exclamation point right here. So here, I'll do a 6 factorial. You need the number first. So if I go 6, oh gosh, get rid of that. 6. Really? And then, oh my goodness, look at what is happening. I hate using this. So I have a Surface Pro that I'm using, and when I use it without the keyboard on it, it's really kind of problematic. So I go to function and I hit that, and it tells me over here that's 720. Okay, so that's a huge number, right? Well, think about, let's do something smaller. If I do I'll go backwards. A 3 factorial is just 3 times 2 times 1. Well, that's 3 times 2 is 6 times 1. Excuse me a minute. Jade, get out of the trash can. Thank you. Get out of the kitchen. Go on. Go. Out. My dog was trying to go in the garbage can. Anyway, 3 times 2 times 1 is just 6. So if I go back to main and I go to 3 and then function, hit that guy, there's your 6 right there. Okay, so that is how that works. It is in the calculator. If you don't have the Desmos, this app on your phone, it is an app, by the way. I should put it on your phone if you haven't already at this time of the year. All right, so, oops, that's not where I want to be. Let's go back here. So that is how that would work. And so I calculated these already prior to being here so that I had them ready to go, but some of them, so this is just a 1 factorial, which is 1. 2 factorial, oops, is 2 times 1, which is 2. 3 factorial, we just said, is 3 times 2 times 1. That's just 3 times 2 is 6. A 4 factorial, oops, doesn't get too big too fast. A 4 factorial is just, here, let's do this. 4 factorial is 4 times 3 times 2 times 1. Well, 4 times 3 is 12, times 2 is 24, times 1 is still 24. So this is 24. The 5 factorial, however, gets pretty big, and that's 24 times 5, and that is 120. Okay, so those numbers get pretty big pretty quickly. One more that I thought about that we should probably put on your paper is, it's too bad we can't get it in there the way it is, but, also about your factorial. So one more thing about a factorial, this is just an important note that you should have. So 0 factorial is equal to 1. You should know that. It'll probably come up in the next, not next chapter, maybe next chapter. We talk more about factorials in there. And then you use them a lot in 11.6 and 7. So just so that that's in there. Oh, so also let's do this guy. The summation from I is 1 to 5 of negative 1 raised to the, do I want to do raised to the n? Yeah, raised to the n. All right, so what will happen with this guy? We'll have a sub 1, a sub 2. So this is going to be negative 1 to the 1, negative 1 squared, negative 1 cubed, negative 1 to the 4th, negative 1 to the 5th. Well, what happens every time you raise a negative to an odd power? Negative to an odd power. Versus a negative to an even power. Now, this guy is always, the result is always odd, right? And, I'm sorry, negative. And if you raise a negative to an even power, this is always a positive. So when we raise a negative 1 to the first, we get negative 1. If you square negative 1, you get a positive 1. Negative 1 cubed is negative 1. Negative 1 to the 4th is a positive 1. Negative 1 to the 5th is a negative 1. So if you ever see alternating terms, like the signs on your terms, there's got to be a negative 1 to the n somewhere in there. All right. Yeah, they can get really tricky sometimes. All right, so remember, I'm going to flip my page, so I'm going to do this. We're in 11.4. Okay, add some paper. And here are how the first 9 problems, I think 9, I might have gotten rid of one maybe to make an even 15 problems in your homework. It says expand and simplify. And then it says the summation as I goes from 1 to 4 of 3i plus 1. All right, so we are going to go a sub 1, a sub 2, a sub 3, a sub 4. So you're going from your low to your high in terms of your number of terms. We're going to evaluate these guys. So we're going to go 3 times 1 plus 1, 3 times 2 plus 1, 3 times 3 plus 1, 3 times 4 plus 1. Now, these are just numbers. There's no expressions in here or anything else to do with them. So this is going to be 4, 7, 10, and 13. Excuse me. And then because these are all like terms, not expressions, like x plus 4, x plus 7, you actually add them together for the sum. And that's what they're talking about when it says simplify. So when you add these together, you're going to end up with 34. And you do need that in varsity. All right. We have a few more examples here that we are going to do. The next one says expand the summation as I goes from 4 to 9. So notice that our lower bound is not 1 this time. X plus 3i raised to the I plus 3 power. All right, so these can get a little bit interesting. So we're going to go, I'll change my pen color here. So we're going to go a sub 4, a sub 5, a sub 6, a sub 7, a sub 8, a sub 9. And I just want to make sure I have plenty of space. So remember that an x is an actual variable. I is being replaced. So this is going to be x plus 3 times 4. And I would write this out this way. You don't have to, but I like to be cautious. And then this I is also 4. So what I have here is x plus 12 to the 7. And then my next term is x plus 3 times 5 times 5 plus 3. And I like to write all mine out first. X plus 3 times 6 times 6 plus 3. X plus 3 times 7, 7 plus 3. X plus 3 times 8, 8 plus 3. X plus 3 times 9, 9 plus 3. And then I'll go back and, so I have x plus 15 to the 8, x plus 18 to the 9, x plus 21 to the 10, x plus 24 to the 11, and x plus 27 to the 12. Now, in varsity, you're quite literally, these are not like terms, these guys. So you're going to string these all together. Oh my gosh, string, string together as one giant expression. So your answer in varsity would quite literally look like this. That entire thing is your answer. Okay? The whole darn thing. All right. Next one. Let's expand the page before we even start. Okay. And this is just to give you an idea of how different these can all look from each other. So the summation as I goes from 2 to 5 of x minus 2i over x plus I raised to the 2i. All right, so these ones I'll just string out as we write these guys out. So we're putting in 2, then 3, then 4, then 5. So I have x minus 2 times 2 over x plus 2 all raised to the 2 times 2. So that's when I is 2. I'm adding that to x minus 2 times 3 over x plus 3 times 2 times 3 plus x minus 2 times 4 over x plus 4 all to the 2 times 4 plus x minus 2 times 5 over x plus 5. And then make sure that you're simplifying these things. Don't be trying to put that in the varsity. So we have x minus 4 over x plus 2 all raised to the 4th plus x minus 6 over x plus 3 all raised to the 6th. And make sure you've got your parentheses around the outside of these, or else you're only going to be raising the denominator to the 6th power. X minus 8 over x plus 4 all raised to the 8th plus x minus 10 over x plus 5 all raised to the 10. And that orange step is what you would be putting into varsity. All right. Now, in my opinion, the more difficult part of these, because that part's all just plugging into formulas. And this is where you are given the terms and need to find the summation. And these take practice. I'm going to do a few of these here. Boy, this is going to be a long video. Excuse me. I'm going to do a few of these here. There are a few tricks that you can use, but a lot of this comes down to number sense and practice, to be honest with you. So there will be some practice, obviously, but your job, and I mentioned this early on, is going to be to look for patterns. And if you can find those, that's great. So what you're given here, you're going to be given 2 plus 4 plus 8 plus 16. And now, these don't go ... This is a finite sequence or series. So you have 1, 2, 3, 4 terms. Your job is to write the summation. And here's what it says in varsity. They give you this. And they say I goes from A to B, F to the I, where A equals 1. So you know that. Well, B is easy. B is the number of terms. Right? And here you have 1, 2, 3, 4. So there are 4 terms, so you're going to 4. So that's pretty straightforward. Now, the hard part is finding what this is going to be. So personally, I like to list these in a column. So 2, 4, 8, 16. And then you're going to look for a pattern. If you already see it, I mean, this one should be easy. Maybe you see it, maybe you don't. But you may see that they have a common factor. You may see that, I mean, these are all powers of 2. I'm just going to throw that out there. This is 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, right? So if you have a common thing, that's going to go into the formula as a 2. The changing part, let me highlight, the changing part, 1, 2, 3, 4, that's changing by a specific amount is where the I is going to come into play. And so that's where this is going to be 2 to the I. The first time it's going to be a 1, then a 2, then a 3, then a 4. And if you were to keep on going, that would generate that. So that's what that guy is going to look like. Okay. All right. The next one is a little bit more difficult. And then there's a couple of strange ones. So let's see what we got. Okay, given 3 plus 7 plus 11 plus 15 plus 19. Write the summation. Notation where A equals 1. All right, so, oops, that's an I. So I goes from 1. There are 1, 2, 3, 4, 5 terms. So that's going to be true. 3, 7, 11, 15, 19. So what I noticed when I did these was that between every term, there was a 4. So what I tried to do was I kind of started with a 4 and said, if I start with a 4, how can I get a 3? Well, if I take off a 1, I can get a 3. Well, with this one, if I start with a 4 and I multiply by 2, I get an 8, and I take off a 1. And then that kind of became a super solid pattern. I started with a 4, I multiplied by 3, and I got a 12, took off a 1. 16 minus 1 is 15, 20 minus 1. So again, what you want to notice here, if you have things that are similar, the 4s go, they're common all the way down. The 1s are common all the way down. The things that are changing, boom, 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 that's going to be my I value. So this is going to be, this is a 4. This is changing because this is really 4 times 1, right? So that's my I. And then the 1 is static. And so that formula will generate these numbers every single time, no matter what term. So, but it's really like, I looked at it at first, I'm like, oh, they're all odd. They're not all prime. Like, I kind of like go through this whole, are they multiples of 3? Well, yeah, no, because like first I started with 3, and then 3 times 2 plus 1 is 7. And then 3 times 3 is 9, plus 2 is 11. Now I didn't even actually look at this. So 3 times 1 plus 0 is 3. Let's see if this works. 3 times 4 plus 3, that's 12, 13, 14, 15. So here's another way that this could possibly happen. And then 3 times 5 is 15 plus 4 is 19. So this would also work. So let's see. So this would be a 3. This would be my I, because 1, 2, 3, 4, 5. Plus, now these are also changing. So these would have to be in terms of I as well. But this is I minus 1, right? Like here I is 0, because here, so this would be, I would have to equal 1 here. But I need this number to be 0, so I have to take away 1. So this, now look what would happen. If I go 3I plus I minus 1, and I add these together, and I'm certain that varsity would take this because of some crazy thing that I did with another one that took me forever. And then when I saw it, I was like, oh man, what they had is so much simpler. And then I took mine and kind of did this. I combined like terms and I got what they got. So if you see a different formula like this, here's an alternate way to do this. You can put this answer in. This answer totally would be okay. It's exactly the same thing as this. Doesn't look like it right off the bat. And this certainly doesn't look like this, right? This is multiples of 4. This is multiples of 3. But really, I mean, it's kind of the same thing. This is where I love math and numbers are so cool because different things like that can give you the same stuff. And depending on how your brain works, you might see something that your neighbor doesn't. And so if you come to me and say, man, I'm seeing these 3s in here, and I'm going to be like, oh, you're going to have to convince me because that's not what I saw. Convince me. You might not be wrong. You might just be thinking differently, but correctly. So go with your gut with these. Okay. So there's more than one way. And I didn't even, literally, this is not even in my notes. That was just a spur of the moment thing. Could I make it work? Right? Because there's different ways to do these. So anyway, all right. The next one you're going to love because it's got fractions in it. Let's see what we got. So we have 2 more, and then we're done. Okay, so this is the next one, and it is given 7/2. Same dog that got in the trash a minute ago is walking back through, so I was watching her to make sure she didn't do the same thing. Plus 5/4 plus 11/10. All right, so looking at this, that does not have any apparent pattern. That's a 2, by the way, under that 7. Write the summation. Where A equals 1. All right, so here's where I had a little bit of a benefit because I've done these enough that I can kind of think outside the box. And you have to think when you have fractions, you need to consider that you may have reduced fractions. And here's what I mean by that. 3/2 is also 6/4 is also what? 9/6 is also for 12/8, right? These are all the same. But any good textbook isn't going to put 6/4, they're going to put 3/2. So here's a 3/2, but that might be a reduced fraction. So when I look at these, the first thing I consider is the number of terms. And I have 1, 2, 3, 4, 5. Okay, so I have 5 terms. And then look at my denominator. 2, 1. This is 2/1. 2, a 4, and a 10. Oh, good Lord. So my next thought is maybe I could get them all to be The same? Well, that's probably not going to help me. Reduced fractions might help me. So again, number of terms. I start with a 2, I end with a 10. I have 5 terms. So what if my denominators were 2, 4, 6, 8, 10? This one's already 10. This one's already 2. 7, 8, 9, 10, 11. Is that a possibility? They're growing by 1. 8, 9, 10, 11. Sometimes you just got to try stuff and think about what happens. Well, this you can't reduce. 8/4 is 2. 9/6 is 3/4, or 3 over 2. 10 over 8 is 5/4. 11 over 10 doesn't reduce. So this, oh boy. Hey, 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 hey! Children! Who knows what the heck they hear? Sorry, I cannot pause this video. Stop. Please be quiet. So this thing is growing. This is what they started out as, right? Before they're reduced. So we're going to deal with this. And I just kind of guessed and came up with some stuff. So let me rewrite those and then let's see if we can find a pattern. So we have 7 over 2 plus 8 over 4 plus 9 over 6 plus 10 over 8 plus 11 over 10. Now, I think, oh, yeah, A is 1, right? We were told this right at the beginning. A has to be 1. Okay, so I want to look at A has to be 1, A is 2, A is 3, A is 4, A is 5. Well, these are clearly 2 times 1, 2 times 2, 2 times 3. I'm looking at just the denominators. 2 times 5. So this is 2 times I, where the i's are boop, 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 right? Okay, so now let's see what we can do at the top. So I need a 1, 2, 3, 4, 5 in the top also, right? I'm going to change my pen. So I need a 1, 2, 3, 4, and a 5. So my question is, how are we going to get a 7 from a 1? I can't multiply because I'm not going to 7 times 2, and that's not going to work. So I like to look at powers of 2. So initially, I think I went 2 times 3 is 6 plus 1. So 2 times 3, and then I went 2 times 4 is 8, but then 2 times 5 is 10. That's over there. And then I went, oh, wait a minute. 6 plus 1 is 7. 6 plus 2 is 8. 6 plus 3 is 9. 6 plus 4 is 10. 6 plus 11 is 5. And because the 6's are all the same, and then the boop, 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 boop are all changing, then I can write this guy as 6 plus I over 2I. So I have the summation as I goes from 1. We have 1, 2, 3, 4, 5 terms. 6 plus I over 2I. And that's how something like that would be approached. It looks really gross. Again, these can take you a while. They can be guess and check. And don't get frustrated. They just take practice. All right, the last one. I'm not even going to tell you how I tried to do it. I threw out the paper, and then this is why I decided to go back over those ones at the very beginning. And let me just review really quickly. What are they on this page? So these guys, common ones, right? Evens, odds, perfect squares, powers of 2, factorials. Keep in mind the differences between the values. Evens and odds have a difference of 2 between all the numbers. Perfect squares build in odds. Powers of 2 have powers of 2 between the numbers. The factorials have like no rhyme or reason. They're just kind of grody. All right, so Let's go one more page. This is the last actual example. So this says given, I really don't like the color green. I don't know why I use it so often. 13 plus 20 plus 29 plus 40. Oh, that's a plus. Plus 40. Write a summation where A equals 3. So we're starting at 3. So if this is 3, 4, 5, 6. So we're going from 3 to 6. So don't start at 3 and go 4, 5, 6, 7. That would be incorrect. Here, I is 3 to generate that term. I is 4, I is 5, I is 6, right? We'll make sure that you're not counting those incorrectly. Okay? Now, let's go 13, 20, 29, 40. Start by looking at the values between the terms. 7, 9, 11. All right, well, there's those increasing odds, which powers of 2. If you remember that, that is going to make your life a lot easier. Or, I'm sorry, not powers of 2. Oh my gosh. Scratch that. Terrible. Perfect squares. All right, so what we have to do is come up with a formula using perfect squares, either adding or subtracting stuff to it to get these values, right? So what are our perfect squares? So let's make a list of them. We have 1, 4, 9, 16, 25, 36, 49. So you can either maybe start at 49 and subtract to get to 40, or start at 36 and add. So I notice right off the bat that if I take 36 and add 4, I get to 40. 25 and add 4, I get to 29. 16 and add 4, I get to 20. 9 and add 4, I get to 13. Okay, well, remember, our A also has to equal 3, and 3 squared equals 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36. So we can take, this would be our I, right? That's changing every time. I squared. So here, this is going to be I squared. Now that's 3 squared. That's going to give us 9, and we're going to add 4 to it. Right? This is going to be 4 squared, add 4. 5 squared, add 4. 6 squared, add 4. So that's going to... I won't even tell you. It was ridiculous. I probably spent... I don't know, because I didn't want to look at the answer. I just wanted to see if I could do it. And I struggle with these, to be honest with you. Patterns is hard. They're hard for me. Over an hour. And I came up with some crazy formula. I had increasing, I probably had I in my formula 3 times. Blah, 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 blah. I put it in. It was right. And then I looked at the answer and it was this. And I was like, how the heck? And then I distributed mine and a bunch of them canceled out and things happened and I ended up with that. I was like, oh, well, if only I'd seen that at the beginning. So if you recognize this and you remember that things grow in odds and that goes with perfect squares, then you just have to figure out how to relate those perfect squares, right? So I'd start by making a list and then see how you can get from the numbers you have to the numbers you need. Okay? I think that's the last thing in this section. Yes, and the last one might be a big old video too. So this is 11.4. All right. Toodaloo. Bet you're happy that one's over.